In this video, we are going to discuss about the problem on realization of FIR filter. The question is determine the direct form and cascade form and linear phase realization of FIR system function. The h of z is equal to 1 plus 5 by 2 z power minus 1 plus 2 into z power minus 2 plus 2 into z power minus 3. We can write h of z is equal to y of z by x of z. Alright. So, after writing this equation, I can multiply this, I can write y of z is equal to x of z plus 5 by 2 into z power minus 1 into x of z plus 2 into z power minus 2, or x of z plus 2 into z power minus 3 x of z. So, while after taking the inverse z transform, I will get y of n. So, y of n is equal to x of n plus 5 by 2. That z power minus 1 into x of z, I can write it as x of n minus 1 by time shifting property, and plus 2 into x of n minus 2 plus 2 into x of n minus 3. So, first I am going to realize this one in direct form method. So, you can see I have a z power minus 3. So, therefore, I have to draw this z power minus 1 and z power minus. So, if I multiply, I will get z power minus 3, right? So, after that, you can see I have x of n. So, x of n, it is 1, right? So, I have to write it as 1. Then x of n minus 1, I have to multiply with 5 by 2. Next, it is multiply with 2. Another one is multiply with, that is also with 2. Then I have to add these values, right? So, I require 3 adder, right? We can see the above equation. So, if I add these 3, I will get the values of y of n. So, like this only you have to realize the direct form 1 of FIR filter. So, you can see here I don't have any feedback, right? So, next let us go for the cascade form realization. So, this one represent a multiplier and this one represent the add. So, in order to realize the cascade form realization, I have to take the equation, right? So, the polynomial is 1 5 by 2 and 2 1 2. Then you have to make this value. So, if I bring the 1 here, 1 into 2 is 2. So, now I am going to subtract 5 by 2 with minus 2. So, I will get 1 by 2. So, 1 by 2 into 2 is 1. Again, 2 minus 1 is 1. So, 1 into 2 is 2. So, 2 minus 2 is 0. So, I have to make this one as 0. So, I can write this h of z is equal to 1 plus this 2 into z power minus 1. And I can write this one as 1 plus 1 by 2 into z power minus 1 plus 1 into z power minus 2. So, if I make it 0, so it becomes 0 into z power minus 3. So, I can write like this. So, now I can write this one. This is nothing but my original equation. So, if I multiply these two, I will get the original equation, right? Since h of z, I have to represent it as h1 of z and h2 of z in multiplication, right? So, this is similar to the IER filter realization. Okay. So, this is nothing but your cascade form realization. Okay. So, only with the help of this only you can able to reduce this equation. So, I can write this h of z as y of z by x of z. So, that is nothing but h1 of z into h2 of z. Okay. So, this is nothing but your h of z. Like this, you can separate it in any manner, right? So, h1 of z is equal to y1 of z by x1 of z. Right. So, if you represent with the help of direct form 1, direct form. So, you have only one z power minus 1 term, right? So I can draw it like this. So this is your z power minus 1, and the input of this one is x of n, right? So it has to be added. So the polynomial is 1, and here this one is 2. So if you add, we get the value of, so this is your realization of h1 of z, right? So the input is x1 of n, and output is y1 of n. So similarly, I can do it for h2 of z. So what is h2 of z? H2 of z is equal to 1 plus 1 divided by 2 into z power minus 1 plus z power minus 2. So again, if I write this h2 of z is equal to y2 of z by x2 of z. So if I draw this equation, so it have 2 z power minus 1 term, right? Because the maximum value is z power minus 3. So and I have to have 2 adders, right? So the first one is 1, polynomial is 1 by 2, another one is also 1. Right? So these values get added, so you get the value of y2 of n. So this is nothing but your dat form realization. So here you have to modify this one. Okay, you can modify and draw it like this. So how to draw this h1 of z? So you have to draw 1. Okay, so you can see the similar only. Only the I have modified like the cascade form realization. Okay. So this is your h1 of z, and likewise I can draw it for h2 of z. Okay. So have so always you have h1 of z term at the left hand side and the plus in the right hand side. Okay. So just redrawing. Okay. So this is your 1. So now I'm going to, in order to multiply this one, I'm going to join y1 of n and x2 of n. And I can write this x1 of n as x of n and y2 of n as y of n. So this is how you have to realize the cascade form. So the next one is linear phase structure. Yeah. So as you know, this the linear phase structure, it has to follow the symmetry rule. So what is the symmetry formula is h1 of z is equal to sorry, this I can draw the diagram. Okay, you can see, but I can't able to draw it properly, right? So why I can't able to draw it properly means because it has to obey this symmetry rule, that is h of n is equal to h of n minus 1 in minus n. So here how to find the value of n? So you can see the h of n is equal to, if you sign the 1, can write 1 comma 5 comma 2 comma 2 comma 2. So the total value of capital N is 4. Okay. So what is h of 0? H of 0 is 1, and okay, and h of 2 is 5 by 2, and h of 3 is 2, and h of 2 is 2. Okay. So now I'm going to substitute this value in the above equation. H of n is equal to h of n minus 1 minus n. So h of 3 is equal to h of 4 minus 1 minus 3. So I will get h of 0. So whether the h of 3 value and h of 0 value is equal, it is not so. So I can't be able to draw the linear phase structure since it is not symmetric. Okay. So I can't able to realize this above equation using the linear phase structure, as it is not obeying the symmetry rule. Okay. But we can realize this one with the help of polyphase structure, polyphase symmetrical. So it will take the value of h of z. So the h of z is equal to 1 plus 5 by 2 z power minus 1 plus 2 into z power minus 2 plus 2 into z power minus 3. So this has to be in the format of p of 0 into z power minus 2 plus z power minus 1 into p1 of z power minus 2. So you have to take the maximum value as z power minus 2. So this is how we have to realize this one. Okay. So now I'm going to draw this. Okay. So this is my x of n value, and you have to draw the y of z power minus 1 value here. Then you have to realize 1 plus 2 into z power minus 2 as direct form 1 structure, similar to the direct form 1 structure. Okay. So I can draw like this, right? So here you can see always you must have z power minus 2 term only. The similar way I can draw the 5 by 2 plus 2 into z power minus 2 like this, right? So here the polynomial value is 5 by 2 and 2. So you can write this is 2 and this is 5 by 2, right? So the both these two terms get added to get the value of y of 1. So this z power minus 1 term must it has to be multiplied with 5 by 2 plus 2 into z power minus 2, right? So you can draw like this one. So this is the we have to realize the polyphase structure, and so the general form of the polyphase structure is this, like this one. Okay. So I hope this video is useful for you. So this is a very important problem which you will get this problem in the university exam also. So if you have any doubt, you comment it in the comment box. So thank you for watching this video. Thank you very much.